Hi, this is Shakil Ahmed. In this video, I would like to discuss about implementation of ordinal logistic regression in R and the interpretation of results. Uh, Basically, when we have ordinal dependent variable, ordinal responses instead of simple binary or multinomial uh, dependent variables, we need to go for ordinal logistic regression. In most of the health related studies or social, even researches in social sciences, we come up with ordinal variables like in health, you can say different stages of disease or pain severity or depression scale or in psychology most of the variables are made on Likert scale, so we have ordinal categories, and we would like to assess the association of the covariates with these ordinal variables. For example, if the dependent variable is disease severity, then we are mostly interested in uh, effect of, for example, treatment or intervention effect on the response, or we are assessing the causal relationship between exposure and outcome, different type of exposures, how the exposures are relating the affecting the ordinal response variable. So for this purpose, we need to conduct a logistic regression analysis. So, as an example, I took the data from National Health and Nutrition and Examination Survey 2017-18. I have just uh, divided the data for only the one cycle of NHNES. That is, we have only 9,756 observations on 962 variables. So the ordinal variable I am taking as an example is smoking intensity. That is an ordinal variable with three categories: non-smoker, occasionally smokes, or regular smoker. So there are three categories, and these three categories are ordinal. Means the lowest one is non-smoker, and then occasionally, and then regularly, and they are according to smoking intensity. So if this is our response variable, and we say we want to see that how age is affecting, how age is related with this variable, or sex of the respondent is related to this variable. So we just see the variable. We are just removing the categories with missing values. So if you see this variable, that is smoking intensity, it has three categories, and then a seven category that might be the refusals, and 99 that may be unknown cases. For these categories, we have no responses. So I'm just dropping these two categories and keeping only three categories. So I have just uh, uh, taking the population this sample with smoking variable less than 7, and you can see now we have only three categories. And for ordinal logistic regression, we have, although we have glm command as well, but I'm using polar command. For this we need mass package and HMISC package. So I just call these two packages, and we are taking smoking intensity as dependent variable, and this should be as a factor, not a numeric variable. So you need to write as dot factor. So just write, and we have two independent variables, age and sex, and we can run. and we get the ordinal logistic regression results. Now these include the coefficients that are beta 1 and beta 2, and these are intercepts. This depends on alpha 1 and 2 means it means for second category versus first category, and this is third category versus second category. It means if we have three categories, then we have two intercepts, one for category 2 and one for category 3, and there is no intercept for category 1, as it is for as it is considered as the base category. So we are not interested in intercept, we are interested in the coefficient that are for age this is 0.04, and for sex it is 0.07. What does it mean? It means uh, age and sex are positively related with uh, smoking intensity, you can say. But we need to uh, interpret it in more detail. If you see the documentation of R, it gives the probability of Y is less than equal to 1 versus probability of Y is, for example, less than 1, and probability of Y is greater than 1. But then in that case, you need to change the symbols of this exponentiation while interpreting. But if you want to continue with these coefficients, then it means you are just checking the probability of having higher category versus probability of falling in lower category, less than that category. For example, we are just comparing probability of y is greater than 1 and y is greater than uh, less than 1, less greater than 2 and less than 2, and greater than 1 and less than or equal to 1. So we are comparing these things. The equality is with less than sign. So uh, this category means if we can say that a, a person with a higher age is more likely to be falling in a higher category versus in a lower category, that is zero point zero 0.04. So uh, we can express this value in terms of odds ratio, and it will more clear, and we can just interpret in terms of percentages. So basically we have probability of, we are just checking the probability of y is in category 1 greater than 1 versus probability of y is less than or equal to 1. We are checking this ratio, that is basically the odd ratio. In logistic regression, we have probability of y is equal to 1 versus y is equal to 0. But here we are checking probability of y is greater than 1 versus probability of y is less than equal to 1. Similarly, y is greater than 2 versus probability of y is less than or equal to 2. So we are comparing this, and this coefficient is constant for the two categories, this category and this category. We have only this coefficient. This is called the proportional odds assumption. As you are changing the categories from probability of going from category 1 to category 2 and category 2 to category 3, the odds is same. Now we are assuming same odds. So this is called proportional odds assumption, and you need to check this proportionality assumption using parallel hazard assumption, whether beta is constant over the categories or not. If this assumption is not fulfilled, then you need to opt for other methods. For example, you can opt multinomial logistic regression, or you can uh, do something other type of analysis. So we have this, and we can just extract the beta as you have already seen. Uh, these are the beta values, and it will include the t value and standard error as well. And we can compute the p value as we need to report p values as well. So I'm just computing p values for these two coefficients. Basically, the summary coefficient includes all the uh, uh, these coefficients, this coefficient, and the intercepts as well. So I am just selecting the two coefficients only, and I am finding the uh, p-value for these two coefficients. As the standard errors are already given, t-value is already given, then I am finding the p-value using p-norm, and absolute of t is greater than or equal to t value. Basically, I'm just finding the probability of t is less than equal to t, and multiplying it by 2. It will give you the p-value, and you can add the p-value in your result as the last column. Then you will see the final result. That is basically the result we need to report in our papers. So then another thing is we need to report the odds ratio, as I have already said. Then the odds are the exponentiated estimates, and we can also find the 95% confidence interval estimates minus 1.96 assuming normal, and then the standard error. And so you can get the confidence intervals as well. And you can see the final result that includes estimates, standard errors, t-value, p-value, odds ratio, and the confidence interval. And the odds ratio, as we can see, 1 unit increase in age, as 1 year increase in age will result 4% increase of in probability of going from a lower category to a versus a higher category. Basically, we are comparing a higher category versus low category. Probability of Y is greater than 1 means of a probability of belonging to a higher category versus probability of belonging to a lower category. This probability is this odds is basically increasing by 4%, and these are the confidence intervals. And similarly for sex, for females are females have 7% more likely to uh, fall in a higher category versus in a lower category. No smokers to smokers, that is 7% higher in females as compared to males, as we have given value 1 to female, and uh, 1 to male and 2 to female. So increase means we are going from female to male to female. So this probability is also increasing. So it means females are more prone to fall in a higher category versus a lower category. That is that may be 2 to 3 or 1 to 3, 1 to 2. You can just find an odds ratio. So this is the result of an ordinal logistic regression, and you can just compare it with a logistic regression, just making two categories. For example, I have constructed a new variable that is smoking as categories. So I am just taking two or less in 0 and greater than uh, 2 is in category, means 1, I'm keeping 1 in category 0 and 2 and 3 in category 1. So let's see the odds of falling in category 1 or 3 versus 2. So basically we are just assuming as nominal categories. So you can just see using logistic regression and then summary fit, and then you will get the coefficients or the ratio. So again, it is 1.04 almost. So it means the probability of falling in 2 and 3 versus 1 is 1.03. It means with increase in one age, the 1 year in age will cause a 4% increase in odds of going falling in category 2 or 3 versus category 1. Means they are more prone to smoke uh, when the age is increased. So it means the people with higher age is more prone to uh, be a smoker than people with low age, uh, lower age. So this is the interpretation of ordinal logistic regression. So uh, that's all about the simple implementation and uh, its interpretation and implementation. If you want to uh, read more about the ordinal logistic regression and its implementation, I will share a link of my tutorials on WordPress. You can read them, and there I have given the codes as well. You can utilize them. Thank you.